Today we're doing a set of two AMC 10A, Problem 9 and Problem 10 from the AMC 10A of 2022. A rectangle is partitioned into 5 regions as shown. Each region is to be painted a solid color, red, orange, yellow, blue, or green, so that regions that touch are painted different colors, and colors can be used more than once. How many different colors are possible? So here I have this thing, and we have the colors we can use: red, orange, yellow, green, and blue. Alright, so they can be one of these colors, each of these 5 things, as long as 2 of the same color are not touching. Let's just define variables. A, B, C, D, and E. These are all like the areas. Let's just start with A here. There's 5 colors. A can be A. 5 possibilities for A. A is 5 choices. Now, C, it's undetermined. At most, there's 4. There's 4 choices. Now, from that, we get that D can be 3. Because, yeah, it can be 3 colors. Like, at most. It's 3 colors. And why 3 colors? Because there's one case where the color of A is equal to the color of E, and the color of B is equal to C. So only 2 colors are utilized, so we can use 3. Now, from this, we can get that B is 3, colors, I guess. Choices of colors. I don't know why I write choices in colors, but I'll write choices. Choices. 3 choices. Because there's a possibility where the color of A is the color of E, and there's just the color of D. Now, from that, we get that E is also 3 choices. 3 choices, because then again, yeah, it's possible. So there's 3 choices right here, I think. So what we really want to find is how many possibilities, so we just simply multiply all of them together. So 5 times 4 times 3 times 3 times 3 is equal to 27 times 20, or 540. So that is our answer. Moving on to problem 10. We have to care about Daniel's problems. Daniel finds a rectangular index card and measures its diagonal to be 8 centimeters. Daniel then cuts out equal squares of side 1 centimeters at 2 opposite corners of the index card here. At two opposite corners of the index card, it measures the distance between the 2 closest vertices of these squares to be 4 times the square root of 2 centimeters, as shown below. And we want to find what the area of the original index card is. So basically, like Daniel here, he has this index card. He somehow got an irrational number here. Let's get straight into it. So, just because this is 4 square root 2, it doesn't have to go like this. You can't just automatically assume that it will be like that, because it could go out. So now, doing that, let's just draw some stuff here. We draw this missing square here, and that's 1 centimeter in area. Yeah, right there. So now we can further draw stuff, draw lines here to split it in here, like this. And now we can set variables here. Alright, so let's just let this entire length be y and this entire length be x. Notice that these corners are all 1, 1, and this is 1 and 1. Well, all we need to do is find x times y. X times y. By using Pythagoras' theorem, well, first of all, we know that this diagonal is 8, so x squared plus y squared is 8 squared, or 64. Now, we see this inner triangle right here. Earlier, we considered this outer triangle with lengths y, a length of y, a height of x, and a diagonal of 8. Let's consider the triangle where, so these are both 1 here and 1 here. So this is y minus 2, this segment, y minus 2, and this segment is x minus 2. So we now know the diagonal and these two. So y minus 2 squared plus x minus 2 squared is equal to 4 times the square root of 2 squared, which is 16 times 2, or 32. So we can further just write this out. This is y squared minus 4y plus 4, well, not plus 4, but plus x squared minus 4x. It would be plus 4 here, but there's another plus 4 here, so you add 8. Is 32. Now we can solve. Earlier we found out that x squared plus y squared is 64. So this is just 64, well, not plus, minus, take out the 4x plus y, and then you subtract the 8, you get this is, what, 24. Now you can move this around. 4 times x plus, well, don't do that, but you subtract the 24 here, so 40, and then you add this. 40 is 4 times x plus y, so you get that x plus y is 10. Now, why is this important? We can find out, well, x times y, because there's a formula in where x times y is. That's x plus y squared. Yeah, x plus y squared. This is 10 squared, or 100, right there. So now, well, what we can do is we get x squared plus y squared plus 2xy. So 100. And I wrote them together because they're 64. So 2xy is 100 minus 64. Since we subtract 64 from both sides, you get 2xy is 36. X times y is 18. So we have found the original area of the notepad thing that Daniel measured.